Would you believe me if I said that this machine is used to make 3D real-world objects? They're making toys, jewelry, designer clothes, and even pizza? Wow, this is exciting. It has gone even further. They are now printing human organs. I know, this sounds crazy. Let me back up a little bit and give you some information on how bioprinting works, so you understand the method behind the madness. I also want to talk about what they have printed so far and what they plan on doing in the future. Let's go back 30 years. In 1984, a man by the name of Charles Hull made stereolithography, which is printing tangible objects from data on a computer. This is a form of 3D printing. 12 years later, Dr. Garver Forcax observed how cells stick together during embryonic development, and he noticed how the cells move together in clumps, which seemed to have liquid-like properties. Then, in 2003, Thomas Boland, a researcher at Clemson University, was able to modify an inkjet printer so that it could accommodate and dispense scaffolds. A year later, Dr. Forcax came back into the picture, and this time developing a technology to make 3D tissue with only cells this time, without using scaffolds. Then, 2009 to 2010, the leader in bioprinting, which still is today, a California startup organization titled Novo. This is a company that was set up by a research group from University of Missouri and was led by Dr. Forcax. In 2009, it created the first ever bioprinter called the NovoGen MMX bioprinter. Then in 2010, they created the first blood vessel to be bioprinted. Now, Organovo has succeeded in making multiple drug discoveries from human cells.
I know that 3D printing exists, and I've seen it at science museums making like little plastic doodads, but I don't know about tissues like medical, like body tissues. I've never heard about anything like that.
It's a process by which you can print organs 3D and then potentially be inserted into a human body.
Well, 3D printing in general is when you print something off a printer and it becomes a 3D form of it.
Not much, otherwise I mean artificially producing organs to sort of medically aid people. Is that right?
Now, let's talk about how it happens. It's complicated, so bear with me. You'll need human cells from either biopsy of the patient or stem cells. Next, you'll need a hydrogel, which is essentially a network of polymer chains that are hydrophilic. This is where the cells are going to live, and it's filled with vitamins, proteins, and other components for cells to sustain life. Its flexibility is similar to natural tissue due to the fact that it's mostly water. When it's mixed with human cells, the combo mimics 3D microenvironments of normal cells. Without hydrogel, the cells would clump, making them useless. After this process, you will now need a bioprinter. To print an organ for a person, you need to know the shape, size, and where it will be placed in the patient's body. First, CT or MRI scans are taken of the organ, and the images are loaded on the computer to build a 3D blueprint. Next, the scientists have to build the organ slice by slice. Each slice should reflect how the specific cells and their surrounding cells work and fit together in a three-dimensional space. This is very complex, especially in organs that have many different cells such as livers.
Since 2010, various groups have made progress in creating and surgically implementing 3D printed organs. In 2012, doctors in the Netherlands printed a customized anesthetic lower jaw for a woman who was suffering from a chronic bone infection. Then, in 2013, advancements were made in using human stem cells to create artificial organs. Recent work in the field of biomedical 3D printing includes the development and studies of medical research and drug discovery. By using bioprinted tissue, potential treatments are observed in real time. This allows researchers to study the safety, accuracy, and mechanism of action in different types of drugs in printed tissue samples. Currently, organizations are creating tissues through testing services, customized projects, partnerships, and therapeutic applications. Specifically, these organizations are researching the generation and transplantation of several types of tissues, including multi-layer skin, vascular grafts, tracheal splints, heart tissue, and cartilage structures. Once approved, these tissues can be made accessible to doctors and hospitals worldwide.
In the future, our long-term goal is to produce human tissues and organs for surgical therapies and transplants. The benefits? We could decrease wait time for patients needing organ transplants, and eliminate needs for organ donors, and the possible ending to animal testing. However, much work still needs to be done to make this happen. We need more development in science and discovery, more controlled clinical trials to ensure the safety and efficacy, and to gain regular clearance as medical device. Another thing to consider is how printing will impact the drug company. $50 billion are spent on research and development each year, and this produced an average of 20 new drugs approved by the FDA. Potential impacts of bioprinting can potentially impact speed, predictability, and cost of successful future drug discoveries in the future. As with any new advances with science and technology and discoveries, there are a number of ethical concerns that need to be addressed. Despite all the negatives, there are always the argument that bioprinting could be like playing God, and it is simply not natural. Moreover, it raised issues on population control. If we end the shortage of population control, then people will be living longer, and then we will run into the problem if we're creating bionic humans, so to speak. The idea of 3D printing is controversial on its own.
I think if it's safe and well researched, which it obviously has to be if it's going to be used in the medical community, it could be really beneficial and a really cool technology. I think that it's not, a lot of the stuff that we do in medicine could be considered playing God, but it's not, because it's for the greater good of the human race. So, I think that'd be really cool.
If you can better their life experiences as a result of medical developments, then I don't see why there should be any obstruction to that. It needs to be regulated to ensure that there are appropriate safeguards in place, but ultimately if you can better someone's quality of life through that medium, then I don't think there should be any issues with it.
The circumstances in which that technology were developed. So obviously I would argue being able to help people medically is a good thing, but if that's something that's then subject to the market or being commodified, or then becomes another sort of realm in which economic injustice can be enacted, then that's bad. But that's not what sets the morality of the technology itself. So it's the social conditions that technology exists in that determines whether it's good or bad.
Here's another thing to consider. What happens when complex, enhanced organs involving non-human cells are made? Who will control the ability to produce them, and how will they ensure the quality of these resulting organs? Of course, one would say that bioprinting would only be used for the best intentions, but this may not always be the case. People can turn around and use this technology to produce organs or tissues with inferior quality. This could lead to dangerous health issues and could create a black market for human organs. Despite these potential drawbacks, scientists do believe bioprinting, when used for the right reasons, can have huge positive impacts in society. It will be interesting to see what they come up with in the future, for the possibilities are virtually endless.